Welcome back, students. Last class we talked about trees and spanning trees. Today we're going to talk about minimum spanning trees or maximum spanning trees. So a minimum spanning tree is just going to be a spanning tree, but it is going to have the smallest weight possible. And a maximum spanning tree is going to be a spanning tree, but it would have the maximum weight possible. All right, so remember, in order to be a tree, a tree is going to always have one less edge than the number of vertices. Okay, a tree has to be a connected graph. You're going to use all of the vertices. And the last aspect of a tree is the fact that there cannot be any cycles in it. All right, so another algorithm for you to memorize. And actually, I'm going to give you two options, and you will get to choose which algorithm you'd like to use. All right, the first algorithm is called Kruskal's algorithm, based off of the mathematician that created it. First, he says to look at the graph. If it's not connected, don't continue, because obviously there can't be a spanning tree because a tree wouldn't even exist. Then what you're going to do is you're going to list the edges from shortest to longest. Okay, if you're doing a minimum spanning tree. If you're doing a maximum, you'd want to reverse that, longest to shortest. And if you have edges that have the same weight, so for example, CD and DF, it doesn't matter which one you put first. Okay, it is totally up to you. Okay, totally arbitrary which one you put first. Then you're going to go through your table and you're going to darken the first edge on the list, and then you're going to go to the next edge and then darken it. And then on the third one is where you're going to have to start paying attention. If I darken this edge, will it create a cycle? If the answer is no, darken it. If the answer is yes, skip that edge and go to the next one. And you're going to repeat that process until you have one less edge graphed or one less edge darkened than the number of vertices that there are in the graph. All right, so here I have my graph. First thing I should do is 1, 2, 3, 4, 5, 6, 7. Count the number of vertices. There are 7 vertices, which means that this minimum spanning tree will have 6 edges. And then find the edge of the smallest weight, which would be edge FG, which is of weight 1. And then your next edge, which is AB, which is of weight 2. And then we have a tie for 4s. So then just put them in whichever order you want. So I'm going to go CD, which was 4. And then we have DE, which is also 4. And we have DF, which is 5. All right. And then we're going to continue this until our table is complete. All right, so now that I have my table, and again, since I'm doing a minimum spanning tree, all of these edges, okay, my weight, my length is increasing. Had I wanted to do a maximum spanning tree, I'd reverse this. I'd start off with the highest and work my way to lowest. All right, so Kruskal's algorithm says take the first edge, no matter where it is, no matter what it is, darken it. Take the next edge, no matter what it is, darken it. Now on the third one, start paying attention. Are you going to create a cycle? If so, skip that edge and then darken the next one. All right, so these right now are not even connected. Don't worry about it. By the time we're finished, we're going to have a connected graph because it's going to become a tree. All right, so we did FG, we used AB, CD. So CD, that obviously is not going to create a cycle, so we'll use it as well. DE, that's not creating a cycle, so we can use it as well. DF, oh, I have a typo there. I'll change that real fast. So DF, weight of 4. We haven't used it yet, and it doesn't create a cycle, so we'll darken it. All right, BC has a weight of 5, so we'll darken it. All right, now CE, if I were to try to darken it, notice I'd create a cycle. EG, if I darken it, I'd create a cycle. BE, if I darken it, I would create a cycle. AC, if I darken it, I'd create a cycle. I'm actually finished here. Now, why am I finished? Well, remember when we started, we said there are 7 vertices, and I just highlighted or darkened 1, 2, 3, 4, 5, 6 edges, which means this right here is a minimum spanning tree. Now, it's not necessarily unique. Instead of doing BC, okay, maybe I could have highlighted the other ones, but actually it looks like those would have created cycles. So no, actually this one I couldn't have done anything else. All right, but in the future with other graphs, it is possible that your minimum spanning tree is not unique. All right, so one more thing to do. All right, we don't necessarily need to list all of these out or redraw it, but what's important is that we state what is the weight of that minimum spanning tree. All right, so you would just add these up. So add up all of these lengths. That's why I put a check mark next to the ones that I use. So now I know which ones I'm going to add up, add those all up, and that's going to give us a weight of 20. All right, so the smallest spanning tree that we could have here would have a weight of 20. That is Kruskal's algorithm. All right, Prim's algorithm works very similarly, except for the fact that with Kruskal's algorithm, we kind of jumped around where we had our darkened edges, and then eventually we made it so they were connected. Prim's algorithm, you'll always have a connected graph as you work. One thing that I prefer about Prim's algorithm is I don't make a table off to the side. Instead, I just work with the graph. So that means less work for me, in my opinion. But again, it will be your choice which algorithm you'd like to use. So just like Kruskal, Prim said, if the graph is not connected to begin with, don't continue. Then you're going to find the shortest edge on the graph, darken it, and circle its two vertices. If there are two weights that are the same, okay, you get to choose which one you want to use. Find the shortest remaining undarkened edge having one circled vertex and one uncircled vertex. Again, this is going to guarantee that your tree remains adjacent, that remains connected as you're working your way through. Darken this edge and circle it until circle its uncircled vertex. And then you're going to continue this process until you have all vertices that are circled. And again, this is the same graph. We have 7 vertices. That means by the time I'm finished using Prim's algorithm, I'll have darkened 6 edges. So I'm going to find the edge that is of the smallest weight because I'm doing a minimum spanning tree. I'm going to darken it, and I'm going to circle the vertices for this edge. And then I'm going to look at any edge that has one circled vertex. All right, so DF is 4, EG is 5, 4 and 5. I choose the smaller value, and I'm going to darken edge DF, and I'm going to circle this vertex. And then coming off of any circled vertex, we're going to find any edge. So we have edge DC, which is 4, edge DE, which is 4. We also have edge EG, which is 5. So 4 or 4, there's a tie, pick, does not matter which one, darken one of them, and circle the remaining vertex. All right, so coming off of C, we have CA, which is 8. We have CB, which is 5. We have CE, which is 5. Coming off of circled D, we have edge DE, which is 4. And coming off of the circled vertex G, we have GE, which is 5. So a lot of options here, but they were 8, 5, 5, 4, and 5. Choose the one that's of smallest value, which is obviously 4, and circle vertex E. All right, so now EG is out of the picture because that would create a cycle. EC is out of the picture because that would create a cycle. But we could still do AC, we could do BC, and we could do BE. So 8, 5, or 7. 5 is the smallest value there, so we'll darken it and circle B. All right, and then A. We could either do BA, which is 2, or CA, which is 8. 2 smaller than 8, so we'll darken BA, and then we'll circle vertex A. Now all of the vertices have been circled. We have 1, 2, 3, 4, 5, 6 edges, and that has created our minimum spanning tree. This minimum spanning tree, if I add up the weight along all of those edges, it once again is going to be 20. All right, because it does not matter what your minimum spanning tree looks like. All minimum spanning trees will have the same weight. Let me clarify, all minimum spanning trees for the same graph will have the same smallest weight. Different graphs, I'm not saying that 20 has to be the minimum weight for every graph. Okay, it's going to depend on the graph. But if you're looking at the same graph, no matter what your spanning tree, no matter what your minimum spanning tree is, the minimum weight will be the same. All right, so now what I'm going to do is I'm going to use Prim's algorithm. You could apply Kruskal's algorithm if you prefer, but now I'm going to do a maximum spanning tree. All right, so now instead of choosing the smallest weights, now I'm going to go for the largest weights. All right, so for Prim's algorithm, I'm going to choose the largest weight, and that's 8. I'm going to circle both of those vertices. And then coming off of one of those vertices, I have 2, I have 5, I have 4, or I have 5. So I have 2 5s. I get to pick which one I want to use. I'm going to do BC. And I'm going to circle B. Now I can no longer use AB, which I probably wouldn't have wanted to anyway because it's so small. All right, but BE, 7. I have CE, which is 5. I have CD, which is 4. So 7, 5, or 4. Choose the larger value. Circle that vertex. Can't choose CE anymore because that would create a cycle, but I have CD, which is 4, I have DE, which is 4, and I have EG, which is 5, so 5 largest, so I'll darken that edge and circle G. Now I have GF, which is 1, I have ED, which is 4, and I have CD, which is 4. Doesn't matter which one you choose one of them and circle. All right, and then I can't do DE, okay, because that would create a cycle. But I could do DF, which is 4, or I could do GF, which is 1, so I'll choose the larger one. And now I've circled all my vertices, which means my maximum spanning tree is complete. I would then take all of these weights that are next to my darkened edges, and I would add them up, and that is going to give me a maximum weight of 33. That was not a unique maximum spanning tree. I could have, instead of darkening CD, I could have darkened ED. All right, but notice 4, I exchanged a 4 with a 4. I didn't create any cycles. All right, the maximum values stayed the same at 33. So the maximum weight for this graph right here for any maximum spanning tree is going to be 33. All right, so pick which method you would like to use and then practice that algorithm.